This is a charge core revision video. When any two insulators are rubbed together, the electrons from one material can be transferred to the other material. Remember, in an atom, we've got a nucleus at the centre and we have electrons around the outside. And those electrons, when you rub them with friction, can leap onto other objects. One of the most common examples you'll see is either a balloon being rubbed against a surface or the Van de Graaff generator. On the Van de Graaff generator, there's a belt that runs around the inside of the metal dome that you can see. And this is an insulator. And as that rubs past the plastic roller, the electrons are literally torn off of each of the atoms. The thing is, they have nowhere to go, so the electrons tend to build up on the metal surface. And this is what we call a charge. Now, electrons are like charges. That means they're the same charge. And therefore, the electrons want to repel each other. They want to go somewhere, but they can't, unless they're given an incentive. So when you see different effects with the Van de Graaff generator, it's usually because those electrons want to start to move, which we'd call current. For example, you might have seen a teacher take the big metal dome and put it near a small dome. And that small dome is connected with a wire that goes all the way down into the ground. We sometimes use this little symbol. And the ground's really good at absorbing electrons because it's so massive. And so when we move this little dome near the big dome, those electrons can leap across the gap. The further away the small dome is, the further they've got to leap, so it actually takes more of them to do it, which means we need even more to build up first of all. What we tend to see when this happens is a great big spark that leaps across the gap. The closer you move the small dome, the easier it is for electrons to jump across, so we tend to see more often smaller sparks. The reason is these electrons are repelling each other and jumping across onto the little dome where they can flow and move down to the ground. Effectively, they're spreading out. Other tricks you might see with the Van de Graaff generator are when someone holds onto it and their hair starts to stand on end. Well, why does the hair stand on end? Very simply, the electrons build up all over the surface of their hair and the rest of the body actually, and they repel in each other. Key thing to say is electrons repel each other because they have like charges.